welcome back to my channel. Today's topic is P91 Material WPS. So you can see here some various types of joint like butt single-sided and butt groove. Also you can see the various types of parent material. So this is very common and basic type of WPS requirement for P91, and this is very helpful for beginner, those who want to make the WPS. This is very helpful for them. So let's start. So see here, WPS for P91 material, you can see the butt single-sided joint. So butt single-sided joint, so you can see here consumable, we are using the welding process, root and fill and capping. So root, we are using the teak GTAW. Consumable, it is 9CR MOV, and you can see it is the specification, it is mentioned in the packet, the consumable, the packet. The specification will be as per AWH. If you go the year 9090SB9, this is the specification for the particular consumable. If you go the BSEN European norm, then it is coming WCR MO91. So this is the consumable we are using for root. For fill up, if you go the MMA metal SMAW shielded metal arc welding. So MMA manual metal arc welding. So consumable we are using for fill up chromate 9MVN, that is called specification BSEN ECRMO 91B. So two types of different requirement for the fruit and the fill up. So parent metal what we are using, A335 P91 material we are using. If you go the P number in SB section 9, you can see the 5B is for the P91 material. This is for the P number. So thickness is 15 to 16 mm. This is the range. Outside diameter is the 406 mm OD. So this is the WPS thickness. This is the range we can use for the particular in site in weld. So you understand thickness, you understand outside diameter. So this is the three things very important: consumable, base metal. Now we'll go for joint details. So now we'll go for joint details. You see joint details, but single sided. This is manual welding, it will be done. You see single sided means this is the one side, not in the one plate. You can see this is the one plate, this is one side, means this is single side. That is why it's but single sided. Welding position, that is the 5G. So BSEN, if you go the BSEN, that is the requirement, and there is a sketch, the PF is the position, that is for 5G. The joint for thickness, it is less than 20 mm. Less than 20 mm joint for thickness. If you go the F, that is the root face, that is 1 to 3 mm. G is the root gap, this is the root gap, it is 2 to 4 mm. And this angle to this angle, from here to here, this angle, it is 70 degrees. So this is one sketch. So this WPS for this sketch also, another is the right hand side, this sketch also. You see here, that is F also 1 to 3 mm, G is 2 to 4 mm, G is the root gap. Now you can see there is some sketch is something is different. From here it is go like that, and after that. So there is two angle is coming. One is alpha, another is the beta. So alpha is 70 degree and beta is 20 degrees. So two angle it is coming. So this WPS is referred for two joint sketches. Now we'll go for WPS for P91 material single-sided welding details. That is how many run is coming. You can see run is 1 to 7. That is last is the RAM, means the last run, finishing run. So first run is the TIG welding, that is diameter we are using 2.4, current it is coming 70 to 110. Based on the PQR qualification, this is the WPS. But we can also, you can see this is the preliminary WPS. After WPS we have to prepare the PQR, and the PQR finalized. When the PQR is finalized, then the final WPS will need to be prepared. So this is You can see the preliminary WPS. ठीक. This is 2.4 mm diameter. The current is coming 70 to 110. Voltage is 12 volt. DC negative. So it is required for the good penetration. Wire feed speed not applicable. Heat input is 1.2 mm. 1.2 kilojoule per mm. That is the heat input. Second and third run also take 9 CR MOVN, that is consumable. 2.4 mm diameter we are using for TIG. 80 to 140 current. So current is coming more and voltage is same 12. Same DC negative we are using and heat input is 1.2. Now 2, 1, 2, 3 for TIG. Now it is a change 4 to 7 MMA, manual metal arc welding, that is called SMAW welding, that is chromate 9 MBN. So that is ER90S, I think ER90S B9. So these are using for the 90 is B9, it is for TIG, sorry, that is for welding process field is the BSEN ER7 ERCR ECR MO991B. So you can see here. The chromate 9 MBN. So this MMA we are using the two types of diameter. One is 3.2, another is the last one is the 4.0, that is capping. So 3.2 we are using 90 to 130 current and 4.0 it is using 120 to 170. So based on the manufacturer recommendation we are using this current. But after that when you are doing the PQR, maybe this range it will be coming the fixed range. So you can we have to use that fixed range in the weld side also. In the particular in that current and voltage we have to make the good quality of weld. So that is voltage is 24 and it is 25. You see current polarity, so it is coming DC positive and DC positive. So in the 1 to 3 run it is coming DC negative and the 4 to 7 and the last one is DC positive. That is heat input is 1.0 and 1.2. Electrode baking definitely or drying it is required. 300 to 350 degrees centigrade 1 to 2 hours it is required. After that you have to use for portable oven. Gas root. For shielding, you have to use the pure argon. You have to use for root. When you are using the root welding, when you are doing the root welding, so shielding it is pure argon. For purge, also the pure argon. The note one. What is note one mentioned? The maintain purge for runs 1 to 3. So we have to use for purge 1 to 3. So you have to maintain that purge, the pure argon. Gas flow rate is shielding is 8 to 15 liter per minute. For purge, you have to provide 4 to 10 liter per minute. So you have to use the gas flow rate for shielding means 1 to 3. These 3 runs we have to use the 8 to 15 liter per minute for shielding. But we have to use for purging 4 to 10 liter per minute. At the same time, we have to use the purge. Tungsten electrode type, it is 2% thorium TH and the size is 2.4 mm. Details of back gouging, it is baking not applicable. Preheat temperature, it is 200 degree centigrade minimum, but it is 150 degree centigrade is the minimum for TIG. We can use for 150 degree centigrade minimum. We have to use. Interface temperature, it is 300 centigrade maximum. Post-well heat treatment, note 3, what is mentioned, cool to 100 degree centigrade before PWST. So before PWST, you have to cool to 100 degree centigrade. Temperature, it is 760 degree centigrade plus minus 10. We have to use for the final temperature for post-well heat treatment. Time, it is 1 hour per 25 mm towards minimum. So 2 hours minimum it is required. 1 hour for 25 mm. 25 mm thickness for 1 hour. It is the cooling rate. Note for heating and cooling rate, it is less than 100 degree centigrade per hour, above 300 degree centigrade. So this is for the one type, that is bar single weld joint. This is the WPS. Now we'll go for WPS for P91 material bar groove. So welding process, it is not applicable route. We have to go for the fill up direct. Means the route not applicable. The welding process it is coming MMA, SMAW, Consumable is chromate 9 MBVN. Specification is VSEN ECRMO 91B. So parent metal it is coming A335. So you can see here the parent metal in the first one, the parent metal is A335 P91. Now it's also the A335 A217 C120 C12A. So this is cast. This is the cast. After cast it is coming the material, it is coming from them A335 P91. So this is also same P number, it is coming the 5B. Thickness is 15 to 16 mm. Outside diameter it is not applicable, so thickness is 15 to 16 mm. Now how will be looking like this joint sketch? It is butt groove joint. This is the manual. You can see the manual. And ASME it is the 1G position, that is you can see the BSEN with the PA position. So why it is not mentioned root? So you cannot see here the root here. So this is the joint configuration. So the all is coming the fill up. Now you can see the welding details. The process is the three run will become MMA. The chromate is the 9 MBN is the consumable. Three types of diameter they are using. One first run is 3.2, second run is the 4.0, and the third run is 5.0. So run is coming maybe more than 3, but it is not mentioned how much run it is required. But this 3 will be used for the MMA welding process. Current is 90 to 135, 130 to 180 for 4.0, and for 5.0 diameter it is coming 160 to 240 ampere. So voltage is 23, 24 and 25, and the heat input, all the current polarity, all the buses will be current polarity is DC positive. Heat input is 1.2 kilojoule, 1.4 and 1.8. So there is no root that is coming, that's why it is coming the DC positive or the current polarity. Electrode baking only required 300 to 350 degrees centigrade for 1 to 2 hours. So there is no requirement root teak or there is no tungsten electrode. So only the MMA welding, that's why it is required the electrode baking. Preheat temperature 200 degrees centigrade minimum. So it is minimum 200 degrees centigrade. Interburst temperature is 300 centigrade maximum. Post-weld heat treatment is same 740 45 plus minus 10. Time 8 hours, not 2. Heating cooling rate is the same, less than 100 degrees centigrade per hour, above 300 degrees centigrade. So this time is post-weld heat treatment for this particular WPS. Time is 8 hours, 745 degrees centigrade plus minus 10. You can see here now butt groove. This is the different types of joint, also different types of material we have used for parent metal. Now you see here single-sided butt weld. This joint figuration something is different, and we are using the process of the root and fill up is different. You see here the three process we are using here in the root, fill up and fill up, last fill up. So there is three process. One is TIG, another is MMA, another is FCAW. So you see TIG, root, 9CR and the AWS ER90SB9 you are using. MMA is the SMAW welding. Consumable is the chromate 9 MVN AWS E9015B9. This is the specification. And the welding process fill up, it is only the mask, only the capping and the fill up. In the last one, you can say the FCAW, flash core arc welding, that is for super core F91. So parent metal it is same A335 P91, that is for P number 5B, that is thickness is coming 15 to 16 mm, 60 mm. Joint type is single sided bar 12, that is manual. Welding position it is ASME 6G, it is if you go BSEN HL045. So this is 6G position. If it is European norm then it is coming HL045. So consumable, base metal, joint design, these are the all clear for this particular. Now we'll go to the joint design. You see the joint design is the same as the previous slide, but we have changed the some welding process in the fill up and capping. So joint details is single sided bar 12, manual, and welding position is 6G. F equal to root face is 1 to 2 mm. and you can see G 3 to 4 mm, that is for root gap. There is two angle is coming, one is alpha, another is beta, that is 75 degree, and beta is 10 to 20 degree. So this is the actual requirement in WPS. Now you can see here welding details. 1 is TIG, 2 to 6 is MMAW, MMA, and fill is FCAW. So three processes here. One is TIG. First run it will become TIG welding. That is diameter is 2.4 mm electrode. That is 80 to 120 current is required. That is for DC negative. You can see here is because root is required. That is DC negative. Second 2 to 6 it is the fill up. You can say the MMA means SMW welding. That is current is coming 90 to 110 current ampere. That is 3.2 mm diameter is required. DC positive is the current polarity. And fill up is FCAW plus core arc welding, that is super code F91. That is the diameter of the filler weld, that is 1.2 mm. That is voltage is 25 to 27, 160 to 190 is the ampere current. So DC positive also, that is not to what is mentioned. Electrode stick out is 15 to 25. So electrode stick out it is 50 to 25 mm. So we are using the electrode baking, same here, 300 to 350 degree. Gas route TIG welding, that is argon, and the purge is argon not 3. Gas flow rate, same, it is 8 to 12 liter per minute. Purge is 4 to 10 liter per minute. Tungsten electrode type and size 2%, TH 2.4 mm. Preheat temperature is 200 degree centigrade minimum, interpost is 300 degree centigrade. And post-hole heat treatment, it is mentioned not 5 watt cool to 100 degree centigrade before PWST. Same temperature we have to follow 760 plus minus 10, that is the maximum temperature. Time is 1 hour per 25 mm, that is the cooling rate. Minimum 3 hours. Note 6, what is mentioned, heating and cooling rate, it is less than 100 degree centigrade per hour. So you see this is the all the basic type of basic WPS fundamental. You can understand the how we have to make the prepare the WPS. This is the basic requirement. So after that you can change here some of the that is current voltage, that is what is the coming, that is not the actual. So in that basis we have to prepare the PQR. In the PQR what is coming the actual range, that range we have to make the final WPS. Now you can see that WPS for this is a but single sided. Now we have to go another one. You can see here this type of, but here you can see. So we have given the previous one TIG, MA and FCAW. Now we have to see TIG here, GTAW, the same BSEN, WCR, MO91, MMA, SMW, Chromate 9MBN, and the fill up is coming the SAW, that is come fill up and capping both. That is consumable is CRMOBN plus LA90, LA491, that is a flux. So specification is BACN SCRMO91, this is a wire. So these two specification we are coming, that is for wire, one is the flux. So this is the changing for above WPS. From the parent metal is A335 P91, that is for P number 5B, that is the same. Thickness is 25 to 75 mm, that is the thickness. Joint type is but single welded, manual is the mechanized. So two types is there. We have to go manual for TIG and MMA, but for mechanized we have to use the saw. So this is the change in joint details. Joint position is 1G. You have to 1GR note 6 is mentioned BSEN, that is called PEA position. In ASME if you go, that is 1G or 1GR. So this is but single sided. You see manual and mechanized. This is will be the joint type. Welding position is 1G, 1GR note 6. It is mentioned BSEN PA also note 6. So we have to see the note 6 here. F equal to 1 to 3, G equal to 2 to 4 mm, and alpha equal to 70 degree and beta equal to 20 degree. So this is the joint sketch details. Now you see what is 6 mentioned. 6 here, what is mentioned, note 6 in welding position. Note 6 is for rotated pipe, head to be 10 degree before TDC perpendicular to pipe. So For rotated pipe, head to be 10 degrees centigrade inclined before TDC perpendicular to the pipe. Now welding details. Run is first run it is coming teak, second to third run also teak, 4 to 7 that is run is coming MMA, and the last run is coming SAW. SAW what is mentioned, note 1, flux is LA491, 20 mm wire extension and 30 mm flux depth. So wire extension should be 20 mm and 30 mm flux depth. So definitely, if it is 20 mm wire extension will be there, so flux depth definitely it will become 30 mm. So this is the notes. We have to follow that in PQA, that depth is coming 30 mm or not. So if it is 20 mm wire extension is there. So this is teak process, first run 2 to 3 run, to second to 3 third run, that is teak, 4 to 7 run it is MMA, and the last run is SAW. So that is different types of diameter we are following and different types of consumable specification we can see here. Teak it is MMA is different, SAW is different. SAW is the same for teak. So the last run. So diameter is 2.4 mm is using 1 to 3 run, and 4 to 7 we are using for MMA 3.2 mm diameter, and the last one is the 2.4, and the current also we are using the different, you can see, understand all this. Also we are using 1 to 3, that is for root 3 run, you can see DC negative we are using. First run is the root, also second and third run we are using the DC negative for the good penetration. Now the last run you can see the travel speed 400 to 5000, that is for the saw wire, that is for mechanized. So heat input is becoming is different. Same here, electrode and the flux drying. So flux we are using for that particular, that is the flux drying, also same 300 to 350 degree centigrade, 1 to 2 hour. That shielding also pure argon, purge also pure argon. Gas flow rate is shielding 8 to 15 liter per same as previous, purge also same as previous. Tungsten electrode size is 2% each, 2.4 mm it is size we are using. Details of black gouging, that is not applicable. Preheat temperature same as the previous, 200 centigrade minimum is note 3, is preheat 153 centigrade minimum for T. So minimum we have to 50 degrees centigrade, 150 degrees centigrade we have to use for preheat for the T welding. Interface is 300 degrees centigrade maximum. And the last one is the post-weld heat treatment, that is also same for previous, 700 760 degree plus minus 10 and 1 hour for 20 mm. Then the cooling rate towards is minimum, not 5. Not 5 is heating and cooling rate less than 100 degrees centigrade per hour, above 300 degrees centigrade. So you understand, in these three WPS, this is totally different types of sketches of joint design, different types of materials we are using, and different types of the process of the welding, fill up, root, and the final capping. So different types of process we are using for welding process. So these are the combinations of the welding process and combination of the joints, how it is coming, how will be prepare the WPS for P91. These are the best example you can understand from here. So thanks for watching this video. Please like, share and subscribe my channel to get the regular video. Those people still not subscribe my channel, please update to get the regular videos. I think it will be helpful for beginner, also the experienced people, to how to make this WPS. Thanks a lot.